Well, it's a really hot day here in Texas, so what a good time to talk about air conditioning. If you want to keep your camper van cool in the summer, then you need to add an air conditioner. If you want to be able to run that air conditioner off grid or from battery power, then you need to find a unit that's the right balance of power consumption and cooling capability. Hi there, I'm Sam Moser. In this video, I'm going to review the Velit 2000R Rooftop Air Conditioner. Beyond looking at the features, build quality, ease of install, and comparing it to some other similar units, I'm going to go over some real-world performance data that I collected, looking at both the cooling capability and the power consumption. By the way, this is an unbiased review and not sponsored by Velit. I purchased this air conditioner with my own money. Let's dive in. The Velit 2000R is a DC rooftop air conditioner. DC means that it runs directly from DC battery power and doesn't need an inverter or a shore power source to power it like a more traditional 120 volt camper air conditioner. This one is available in either a 12 volt, 24, or 48 volt version, so this means it's easy to pair up with whatever the battery bank in your camper is. I purchased the 12 volt version. Camper ACs come in two main styles: rooftop units and split systems. Rooftop units are all-in-one, which makes them easier to install, but they use up that precious roof real estate that could otherwise be used for solar panels, as the exterior of them is usually fairly large. If you're looking for an air conditioner that doesn't take up any roof space, then check out a split system where the exterior portion mounts either underneath the van or on the back of the van. The Velit 2000R weighs 66 pounds. It has 4 cooling modes: normal, eco, boost, and sleep, and 5 fan speeds. The only difference in the cooling modes is basically the speed at which the compressor runs. The 12 volt model is rated at 8,000 BTU and consumes up to 60 amps on boost mode, but as little as 20 amps on eco mode. Stick around for the testing portion at the end, where I'll find out if those rated specifications align with its real world power use. 15 foot of 6 AWG wire is included with the unit, so you don't have to buy wiring separately. The AC also has low voltage protection built in, and you can customize what that low voltage cutoff level is. I think this is a really nice feature to include because I've installed some more expensive air conditioners that didn't have this built in, and I had to add a Victron battery protect in order to get this same functionality. Operating the unit is really straightforward. You just set the cooling mode, the thermostat set temperature, and the fan speed, or you can set the fan to auto. And you can do this either from the buttons on the unit itself or with the included remote control. The noise when running the AC is very reasonable. The spec sheet lists it as 58 decibels in boost mode and 45 decibels in eco mode. From inside, you mostly just hear the sound of that fan pushing the air out. Nothing crazy, just kind of like white noise. Here's what it sounds like on the inside. I'm not sure how well the mic can pick this up, but from outside, you can pretty clearly hear kind of that loud fan noise operating on the roof. So it's not going to be the most stealth, but no air conditioner is, as they're all going to have that condenser that has the fan blowing over it, and that's just how they work. It isn't obnoxious like something like a generator, though. As far as build quality goes, I think it's pretty decent. The interior unit has a simple and clean design and a good fit and finish. Same for the exterior, which comes in either white or black. To me, when handling and installing it, I didn't think it seemed like it was built any better or worse than something like the Dometic RTX 2000, which is probably the closest comparable model. The air conditioner was packaged really well for shipping. It actually came in a wooden crate, although it was disguised in a cardboard box, and then inside the wooden crate it had the typical styrofoam and other padding. After installing mine, I actually had one problem with the unit, which was that the power and mode buttons didn't work, although it worked fine from the remote control, just not on the unit itself. I ended up being able to troubleshoot this myself, though. It turned out that the control board had popped out of place, and I don't think it actually came like that. I think I did this by accident due to the way I was holding it when I carried it up onto the roof. The display panel on the unit does have a few Chinese characters on it, which seems a little weird to me, but that's pretty minor. One more note regarding noise: sometimes it can make a weird rattly noise when operating on low fan speeds, and I heard this myself. This is actually addressed in the manual, where it says you can mitigate the issue by increasing the fan speed. Now, I don't know if that actually solves what's going on, or if that's just covering up the noise. Before going over the installation and performance testing, let's take a look at how the Velit 2000R compares to some other options on the market. Here's a comparison of some other options I dug up. The closest comparable air conditioner is the Dometic RTX 2000, with the biggest difference just being that it costs about $800 more. The BTU rating of the Dometic is technically lower, but in reality it's not, because Dometic is providing the measured BTU output rather than just a rated output. Based on the current ratings being just about the same, I would surmise that the actual BTU output is just about equal. The one odd thing about the RTX 2000 is that it needs a 14.5 by 14 inch roof cutout rather than the standard 14 by 14 inch roof cutout. That's a pretty minor thing, but if you do happen to be installing the air conditioner where you previously had a roof vent, then having to widen that hole just slightly is an added step. Next up, we have the Nomadic Cooling X2 and X3, which again go up in price. If I'm not mistaken, Nomadic Cooling was one of the first companies to bring a 12-volt rooftop air conditioner to the market. From what I've heard, their stuff is built really well and high quality, but it comes with a price tag to match that. The X2 has a very similar BTU output to the Velit 2000R, but the X3 would be a good option if you're looking for something that has an even higher BTU output, as it comes in around 12,000 BTU. Alright, let's see what else we got here. The BeCool 12,000RM RV and the Indel BePlean Aircon are two more that I came across but don't know much about. You can find a variety of off-brand 12-volt air conditioners if you search the big marketplaces online. Some go by brand names like Tree-Ligo or Out-Equip Pro, but others are more generic or just have some random name with them. There's a variety of these models, and they're usually priced around $1,000. Reviews on them seem pretty mixed, with some people having a good experience and others saying they're junk. I'll also throw the Fresair S8 on here, even though it's an evaporative cooler and not an air conditioner. What it is, though, is really low power, as it only consumes 10 amps of current at 12 volts, and that's just for the fan and the water pump. For really dry climates, it can be an option, but don't expect to get much of a cooling effect from it if you're in an area with moderate or high humidity. Let's talk about the installation process of the Velit 2000R, which I'll just give a quick overview of. Since this is an all-in-one unit, the install of it is pretty simple, and it comes pre-charged with refrigerant. Other than being a whole lot heavier, I'd say the install of this isn't much harder than something like a roof vent. You need a 14-inch by 14-inch roof cutout, which is the same size as a typical roof vent. In my van, I was replacing a roof vent with this AC, so I already had the hole in the roof cut out. I also had a roof vent adapter glued in place, which creates a flat surface where you mount it. I left that in place. Air conditioner specific adapters are also available, which can be good to use since the roof on these vans, especially Transits, has the ribs in them, but it's also fairly curved overall. The air conditioner comes with a foam sealing gasket. This gets adhered to the roof cutout using sealant. I used some 3M window weld because it's what I had extra of available, but normally I'd recommend using a marine adhesive sealant for this, like Sikaflex or 3M 4200 Fast Cure. In addition to the foam gasket, these foam support blocks are also included. Since my roof cutout adapter adds some height and the roof curves down, I cut out some pieces of HDPE and stacked them with the foam blocks using VHB tape to make the blocks the right height to actually add support. I had to add a ½ inch to the outside blocks, but ended up only needing to add a ¼ inch to the rear blocks. With the gasket and blocks in place, I was ready to lift the air conditioner up onto the roof. Due to the weight of the air conditioner, this is the hardest part, and I definitely recommend having 2 people available to do it. Once on the roof, you can drop it into the hole. To check if it's positioned right, look from the underside and check that both the front and back bolt holes are accessible. Next, you can connect the wires inside. I did this before bolting on the brackets, so I had a little more working room. Then you add the threaded rods, followed by a nut on each one to lock it in place. I had to glue in some blocks, again using HDPE so the mounting brackets could sit flat, as both were right against the edge of an interior roof rib. But this is hard to see since my ceiling is covered up already. Finally, add the mounting brackets and secure them with a washer and lock nut. These should be torqued to 3.3 to 4.2 foot-pounds. You'll probably need a deep socket to tighten it depending on how much threaded rod is exposed. And that's it for the install, other than connecting the other end of those power cables to your power source. One thing I found I didn't quite like about the wiring included with the unit is the bulky connectors/fuse holders that are used to tie the wires into the leads at the unit. I don't think a fuse at this end is really necessary, so I think it'd be nicer if it had a slimmer or more integrated way to interface the wires. Nonetheless, there's enough room to tuck away these connectors behind the ceiling panel. Velit also provides a trim ring you can install around the unit if that works better for your ceiling paneling. And that's all the notes I have about the installation of this unit. Now for the fun part, performance testing. I'll go over the measured power usage and then 2 cooling tests I ran in the Texas heat. One for fighting that midday heat, and the second for cooling down the van after the end of the day. I don't have an electrical system set up for this van yet, so I used a 1000 watt, 120 volt to 12 volt converter as my power source for the testing. I then connected a clamp meter on one end of the supply wires to measure the current. Then I set the AC to the run mode and fan speed I wanted to test, and then waited for the current to stabilize and recorded that value. I left the thermostat set to 64 degrees for all tests. I also measured the voltage both at the power supply and at the wire connectors by the unit so that I could calculate the voltage drop when using the supplied 6 AWG wiring. Here are the results I measured for the operating current. I think it was mostly as expected, except for in boost mode where I'm not sure why the fan speed had a much larger impact on the current than in other modes. There's a pretty steady increase in current as you move from sleep to eco to cool to boost modes. The fan speed definitely has a much lower impact on the operating current than the mode does, which is what changes the compressor speed. The max current was pretty close to the advertised max of 60 amps, with the highest I measured it being 58.3 amps. Eco mode was actually a little higher than I expected, and sleep mode, which came in around 25 amps, was more what I expected to see out of the eco mode. In my cooling test, which I'll show next, I found that the current didn't stay consistent based on the operating mode, but it varied based on how hard the air conditioner was working, which may explain why I saw this higher current in eco mode here. I took these measurements at about 5 p.m. on a hot, clear, sunny day when the exterior temperature on my thermometer outside, which was sitting under the shade sail, still said 105. I don't doubt that eco mode could be as low as 20 amps in more moderate weather conditions. It's just not what I measured. I saw that it was more around 35 amps. The voltage drop with the supplied wiring stayed under 5%. Here are my measurements for that. As is expected, the amount of drop increased as the current increased. The power supply I was using had a little bit of fluctuation in its output, which I think explains the variance in my measurements here, as I couldn't measure both the supply and the unit right at exactly the same time. Nonetheless, 5% voltage drop at the highest current is pretty reasonable, so all good with the supplied wiring. Now for the cooling tests. For the first scenario, I wanted to see how well the AC could keep the van cool through the worst of the midday heat on a really clear, hot, sunny day. I parked the van so it was just about in full sun, and in the morning it was coming down kind of right on the front windshield of it, and then it shifted to the side and then the back as the day went on. I had a standard sunshade in the front window, but not a full, blackout shade, so it really only had partial coverage. If you were really trying to keep the van cool, you could have this front area better protected. Also, currently the van is insulated on the walls and ceiling, but the floor is just bare. I kept the doors on the van closed for the test, but I did had to briefly open one of the front doors once an hour to go in and measure the current. I did this on the door on the shady side, and I tried to open and close it as quick as I could. I used 4 temperature sensors and recorded readings every 30 minutes. The first was in the rear of the van at about mid-height, which is about the height a bed platform would be, which I expected to stay cooler since the AC is in the rear. The second was hanging just behind the driver's seat, again at a middle height. The third was on the floor under the air conditioner's location, just for another reference point. The fourth sensor was on the display, which I kept outside to measure the exterior temperature. I had this under a shade sail, which provides shade, but isn't quite full shade as it still lets some sunlight through. For the test, the air conditioner was set on boost mode, the highest fan speed, and I had the thermostat set to 64. Here are the results running from about 10 a.m. to 4:30 p.m. By 11 a.m., even with the exterior temperature rising, the interior cooled down a few degrees, reaching a low of 83 degrees, averaged between the front and back sensors. But from this point on, as the sun beat down on the van, the temperature inside slowly rose. At the peak afternoon temperature of 107, the interior temperature reached 88.5 degrees. I also looked at the cooling temperature differential between the exterior temperature and the average between those front and back sensors in the van. Here's what that looked like. The largest delta was at the hottest point, where the difference between the interior and exterior temperatures was 18.5 degrees. Lastly, here's what the operating current looked like through this test. It started at 52 amps and ended at 58 amps. So this is what I meant earlier when I said that the operating current seemed to depend on how hard the air conditioner was working, as the run mode and fan setting were consistent through this whole test, but the current fluctuated. While I wasn't measuring the amount of power consumed during the duration of this test, we can do some back-of-the-napkin math for a rough estimate. Let's say the average current was 55 amps and we were running for 6.5 hours. 55 amps for 6.5 hours would be just under 360 amp hours at 12 volts, which in terms of battery capacity is quite a bit. For the second test, I wanted to see how well the air conditioner could cool the van at the end of the day after the van had been sitting there parked in the heat. Say you got back to the van after a day of adventure and wanted to cool the van down while settling down for the evening. I actually did this test the day before the first one I showed, so the van hadn't been sitting there with the AC running. Instead, it had been sitting outside with no AC on all day. I ran this test from 5:30 to 11 p.m., and I had the AC on the normal cool mode instead of the boost, but I still had the fan speed set to 5 out of 5. Temperature sensors were in all the same places except for the floor sensor, which wasn't there. Here are the results from this test. Again, I kept the doors closed except for brief openings to go in and measure the current, but I think these quick openings and closings of the door are more consistent with real-world use anyway. From the start, the AC was able to drop the interior temperature faster than the exterior temperature was dropping, but really it took quite a bit of time until it got below 80 degrees inside. By the end of the test, the interior was down to 70 degrees, which was a 14-degree difference from the exterior temperature. Here's the full run of temperature differentials from start to end. Lastly, here's what the operating current looked like. It started at a high of 53 amps, but ended at only 39 amps. This is a pretty big fluctuation, but towards the end of this test, it was night, it was fully dark out, and the AC was no longer working as hard, so I guess it makes sense that that current dropped. Roughly 240 amp hours of power at 12 volt was consumed during this time to cool the van down, which is a pretty significant chunk of power. But I do think if you were to switch it to sleep mode at this point and just try to maintain the temperature through the night, that it would use a lot less power through the rest of the night. So that was my testing. Overall, I think this is a good unit. While the cooling test during the afternoon heat may seem underwhelming in terms of what that interior temperature of the van was, I think that's just what you have to expect out of a unit of this size and power consumption. For a point of comparison, a traditional 120 volt rooftop AC usually has a BTU output of about 13,500, whereas this one only has 8,000 BTU. It's a trade-off of power consumption versus cooling capability. I did see on the Velit website that they have a 4000R model coming soon, and this will have a cooling output of 13,500 BTU, but they don't have the power specs listed for it yet. Depending on how you plan to use your camper van, the Velit 2000R could be a good option, especially for keeping the van cool at night without having to have a crazy huge power system. So for this unit, I think the price is good, I think the quality is good, and I think the power consumption is moderate for air conditioning, which is a very power-hungry task. The only thing I can't speak for on this unit is the longevity of it, and only time will be able to tell on that. That's it for this review. I hope this has been helpful. Thanks for watching. If you enjoyed this style of review content, let me know below. Alright, see you in the next video.